Okay, today we're going to look at the 7.3, which is the binomial expansion. So to get us warmed up, I want you to evaluate a plus b squared. And there's a couple different ways you could do it, but I think most of you think about it as a plus b times a plus b, and then you can distribute, right? So then we get a squared plus ab plus ba plus b squared. And AB and BA are the same thing, so we could rewrite it as a squared plus 2AB plus b squared. Now if I take it a step further, and I say a plus b cubed, that's really a plus b times a plus b times a plus b. And we just figured out this, right? We just said that that is a squared plus 2ab plus b squared. But once again, you're going to have to distribute, right? So we get a cubed plus a squared b plus 2a squared b plus 2ab squared plus b squared a plus b cubed. And I distributed and kind of thought about it as like a times both those, and then like this middle term times both those, etc. You're also welcome to do the box. Okay, so as we look at combining like terms, here we've got 3a squared b. We got an a cubed up front still. We also have an 2ab squared and a b squared a. So that's 3ab squared and then a b cubed at the end. So we know we can multiply this out. The problem is as you get higher and higher powers, like let's say something to like the fifth power, like a plus b to the fifth, it just gets longer and longer and more cumbersome to do this arithmetic. So there are some shortcuts. Complete the following pattern. So you may recognize this, I think a lot of you do, kind of from previous years. This is called Pascal's triangle. So the ones continue down on the outside, and then to get to this box, we add those two previous ones. So 1 plus 3 is 4, 1 plus 4 is 5, 4 plus 6 is 10, 4 plus 1 is 5. And you'll notice it kind of mirrors on both sides of things too. So this is 6, 15, 20, and the other side goes opposite, 15, 6, 1. Okay, I can keep going. I'm going to do like 2 more rows. 7, 21, 35, 35, 21, 7. 8, 28, 56, 70, 56, 28, 7. And you can continue on. I'm just going to say ... It's probably not worth our time here, but yes, this pattern just continues. And we call this Pascal's triangle. And what do we notice about this triangle and the coefficient and the warm-up? So as you look here and notice how like we have 1a squared, 2ab, 1b squared. And look at this row. Then we got 1a cubed, 3a squared b, 3ab squared, b cubed. Look at the next row. So all of a sudden you'll see that the coefficients of the polynomial, right, from our warm-up, match a row of the triangle. So this is for like squared, and this was for like cubed, etc. So you'll notice it's kind of one off. This is like the 0 exponent, 1 exponent, 2 exponent, 3 exponent. So this one would be 4, etc. I'm going to go through actually real quick and just do that in a different color. So it's for like 0. Oh, I changed all the colors. I didn't mean to do that. Give me 1 second. Try that again. Okay, so now if we wanted to use Pascal's triangle to expand the following, we would make our lives a little bit easier, right? So the way it works is if we have something raised to the second exponent. I usually think about, okay, the second exponent's going to have 3 terms. So we're going to look in our squared. We're going to use this row right here. So we got 1, 2, 1. So we're going to have our coefficients. We got 1. I'm going to draw like a line down, 2, and then 1. So now we're going to look at kind of like the first term. So 2 to the power of x, and we're going to raise it to the second power. And then we descend. So this is raised to the first power. This is raised to the 0 power. And then we're going to do the second term, which is -3. We do the opposite here. So raise it to the 0 power, and then to the first, and then to the second. So you got 2 kind of options here. You can either look at simplifying like 2x squared is 4x squared. 2 to the first, 2x to the first is 2, this is 1. This is 1, -3, 9. And then multiply that on the column, or you could just multiply down the column and kind of do that arithmetic as you go through. So now we're going to look at the column. So as we multiply down this column, we get 1 times 4x squared times 1. So we get 4x squared. The next one, we get 2 times 2x times -3. So we get -12x. We do 1 times 9, so plus 9. So this is the resulting polynomial. Okay, same idea of this next one, but it's going to be a little bit harder because we've got to the 5th power. So that means that there are 6 terms. So we've got 1. I usually do like the little kind of column down just to remind me that it's a different term, but it's up to you. 10, 10, 5, and 1. So we're going to do 3x to the 5th, and we're going to descend the exponents. So then to the 4th, and the 3rd, and the 2nd, and the 1st, and the 0 power. And then we'll do the same thing with the -4y, but go up. So 0 power, 1st, 2nd, 3rd, 4th, and 5th. Okay, this is the part where you're probably going to want to use a calculator, right? So like 1 times 3 to the 5th times -4 to the 0 is what I type in my calculator, and I get 243, and then I get x to the 5th, y to the 0 is just 1. So then 5 times 3 to the 4th, -4 to the 1st, so we should get a negative, and we get -620 when we put that in our calculator. We've got x to the 4th, y. So now we've got 10 times 3 to the 3rd times -4 squared, so we should get a positive again. And we end up with 4,320 x to the 3rd, y squared, minus 10 times 3x squared, so just the 3 squared, and then -4 cubed, so we should get a negative again. And let us kind of keep switching signs. We get 5,760 x squared, y cubed, 2 more terms now. 5 times 3 times -4 to the 4th, so plus 3,840 xy to the 4th, minus 1 times 3 to the 0 is just 1, so -4 to the 5th is 1,024 y to the 5th. And this would be your resulting polynomial. Okay, so if you like Pascal's triangle, that works, and you can continue to use that. I do want to show you one other way you can think about it. So 7 minus 2 factorial. This is the same as 7 minus 2 is simply 5 factorial, which factorial is just another way to say 5 times 4 times 3 times 2 times 1. There is a shortcut in your calculator which makes life a little easier, so we get 120. This one, if you think about what it's saying, 10 factorial, that's 10 times 9 times 7, 8. Don't forget 8, 7 times 6 times 5 times 4 times 3 times 2 times 1, all divided by 6 times 5 times 4 times 3 times 2 times 1. You'll notice like the 4s, the 5s, the 6s, the 3s, the 2s, the 1s will cancel. So we're really just left with 10 times 9 times 8 times 7. You can either type that in manually, or you can type in 10 factorial divided by 6 factorial. Either way you do it, you should get 5,040. The reason why we show you factorials is if you look at your formula sheet, there's actually a formula here that will help us with the binomial theorem, and it's called like n choose k. If you've taken statistics, there's actually a shortcut, n choose r on your calculator that is the same exact formula. And it's called a combination in statistics, but it's the same idea. So there's two ways to do it. You can either plug things in the formula. When we have 7 and 4, that's really 7. So you got 7 total objects, you're choosing 4 of them. We do 7 factorial over 4 factorial, and then 7 minus 4 factorial. So it's the same as 7 factorial over 4 factorial times 3 factorial. Make sure if you type that in your calculator, put parentheses around the bottom. So we get 35. And a cool little shortcut for you, this is the 7 is 7, choose 4. Same idea here. You get 25 factorial over 11 factorial, and then 25 minus 11 factorial. So 25 factorial over 11 times 14 factorial. Same as 25, choose 11. And we end up with a lot more options here. 4,457,400,000. The reason why they show you this is because this is another way to figure out the coefficient. So, hey, if I have something pretty small, you can do Pascal's triangle. But if I ask you something to like the 20th power, you're not going to want to go all the way through Pascal's triangle to figure that out. So you'll notice, hey, the coefficient, so if I'm ever expanding something, a plus b to the end, the coefficient of the first term is just 1, the coefficient of the second term is n choose 1, and then the third term n choose 2, etc., etc. So that could help us out. On this first one, I don't mind either way. Use Pascal's triangle, 4th power is not too bad, or use the binomial expansion. I'm going to just show you the binomial expansion here, but you'll kind of see how it relates. So our coefficients are 1, and then 4 choose 1, and then the next one is 4 choose 2, and then I would have 4 choose 3, and one last one will be 1 again. You can technically do 4 choose 0 and 4 choose 4, and you'll get 1 as an answer there too. But when we type these in our calculators, n choose 1, 4 choose 1, we get 4. 4 choose 2, we get 6. 4 choose 3, we get 4. So it is the same coefficients as we have in Pascal's triangle, right? 1, 4, 6, 4, 1. Okay, then we'll do the same thing we did before. So 5a to the 4th, 5a cubed, 5a squared, 5a to the 1st, 5a to the 0. And then we get 2 to the 4th. Sorry, 2 to the 0. We'll go the opposite way with this one. 2 to the 1st, 2 squared, 2 to the 3rd, and 2 to the 4th. Okay, so then you just multiply down the column and add those terms together. So 1 times 5 to the 4th times 2 to the 0, that's just 1. So we get basically 5 to the 4th, we get 625, a to the 4th. Plus 4 times 5 cubed plus times 2, we get 1,000, a cubed. Plus 6 times 5a squared times 4, or 2 squared, is 600, a squared. Plus 4 times 5 times 2 cubed is 160a. Plus 1, 5a to the 0 is 1, so 2 to the 4th is just 16. Okay, These next ones are a little bit more of a puzzle because you'll notice we have these higher exponents. So even the 8th, like you'll notice we didn't even do our chart. We barely did our chart far enough to go to 8. So in that case, you could do it, but it's going to waste a lot of time if you're on a test and you've only made it to like row 4 to come up with this. So here, when we're saying we want the 4th term, okay, I sometimes kind of think about it logically for just a second. So I think, okay, we start off, we've got the first term, first, second, third, 4th term. Okay, the coefficient of that 4th term, we're going to the 8th power, so it's 8, and this is like choose 0, choose 1, choose 2, choose 3. So 8, choose 3. If you type that in your calculator, plug in your formula with like 8 factorial over 3 factorial times 8 minus 3, so 5 factorial, we end up with, sorry, I thought I had this right in front of me, and I don't, so I'm going to have to type it in. Give me 1 second. 8 choose 3 factorial, 8 choose 3. So, on our calculator, math. Okay. So 8 choose 3. We get 56. And notice that does match as we look up here. 1, 2, 3, 4th term should have a coefficient of 56. Okay. So now I'm going to think about the 7. So this would be to the 8th power, 7, 6. So this is to the 5th power. So we're going to do 7 to the 5th. And I get 16,807. And then we're going to do 5y. And this is 0, 1, 2, 3. So it should match what we have up there, 8 choose 3. Okay, so 5 to the 3rd is 125. So 125y cubed. So to come up with my final term, I'm going to multiply all those things together. 56 times 16,807 times, sorry, that was 125, not 123. Y cubed. So let's see what we get. So if we times all of these together, we end up with quite a large coefficient. We get 117,649,000. So 117,649,000 y cubed is the 4th term. Okay. Another way I could do this, okay, notice I've got another one, which has got a large exponent. We definitely did not do our table out to the 10th. But we want to know which term contains x to the 24th. So something like that, I'd kind of think about, okay, my 3 like kind of spots here, right? My coefficient, my first term, and then my second term. So here we're going to have x to the 4th raised to something. Here we're going to have 4 to the something. We have to figure out the coefficient too. Since we want it to be x to the 24th, I'd almost say to myself, okay, well, the only thing that has an x is that first term. So what am I going to have to raise this to get to the 24th power? I'm going to have to raise it to the 6th. But be a little careful here. So you may be like, 6, oh, it's the 6th term, right? That's a little bit different, right? Because if you go 10, 9, 8, 7, 6, this is your first, second, third, 4th. We're talking about the 5th term here. So which term is this? This is the 5th term. Okay. So now let's think about that coefficient. There's 10 total, so we're going to do 10, choose, but then you do 0, 1, 2, 3, 4. 10, choose 4. And that should match the exponent here. You'll notice the 10 and the 4 always add up to be 10. So that's another way to kind of think about things to make sure you're doing things correctly. They all kind of seem to correspond to give you that total of 10. So this is 210 when you type in your calculator. And then this one, when you do 4 to the 4th, we get 256. So then for that term, we're going to multiply all these things together. So we're going to do 210 times x to the 24th times 256. And we get, so our fifth term is, let's see if we can figure out this. So when we multiply those together, we get a so the fifth term is 53,760 x to the 24th. All right, you should be all set for your homework.